Good morning, ladies and gentlemen. I'm Rosemary Bartlett with the Pacific Northwest National Laboratory, and I'd like to welcome you to today's webcast, Standard 90.1 2007, an overview of the lighting and power requirements, brought to you by the U.S. Department of Energy's Building Energy Codes program. We're very happy to have as our speaker today Eric Richman of the Pacific Northwest National Laboratory. Welcome, Eric. Please begin.
Thank you. This is an overview of the ASHRAE IESNA Standard 90.1 2007 lighting and power requirements. And we will be covering the entire set of requirements in as much detail as possible. But I will make sure and the changes, differences between the 2004 and 2007 standard, because a lot of this material is the same in 2004, but we do want to highlight what's changed in 2007. So I'd like to start with a little bit of the basis for energy requirements, why we have them and why we're discussing them today. As some of you may recall, there was an Energy Conservation and Production Act back in '76, which has been amended by EPAC a couple of times at least. Part of the requirement in that act is that states adopt a commercial energy code, and this is what drives states to go through the process of looking at energy codes and coming up with one and adopting one for use in their state. Part of the requirement is a role for DOE, which is to determine the effective stringency or level that code must meet for a state to adopt for the buildings to comply with. And currently that's the 2004 standard. As many of you may recall or may know from your own experience in design and compliance, there are many code standard versions available and currently adopted. It varies quite a bit by state. Some states have adopted a nationally available code or standard, such as the 90.1 2007. Some states have developed their own code, which may or may not be based on a national code. And some states still do not have a code. They may be currently developing one or are looking at adopting a nationally available code. A way to graphically look at this, looking at adoption across the country, as you can see, there's quite a bit of variety. A variety of adoption from the 1989 one of the original ASHRAE codes up through the most recent 2004 version. Some states, you'll see with the asterisk, are adopting by a county or jurisdictional basis. Home rule states don't have an overall code. Some of them don't. Anyway, quite a bit of variety there. So let's move into the code itself with some basics of Standard 90.1 2007. It is jointly sponsored by ASHRAE and IESNA because there are lighting as well as HVAC and envelope provisions. 2007 is the brand new version, but as you saw before, there are many other codes in place from 2004 clear back to the '89 version, which are adopted in various levels by different states. Many state-specific codes and the IECC, which is another nationally available code, are based on the provisions that were developed through the 90.1 process. IECC itself references 90.1 as a compliance option. So a lot of what we're going to talk about today will be very applicable, even if the state hasn't adopted the 90.1 code itself. So on to some specifics, and I'd like to start with the power requirements. There are very few of those, so we'll dispense with those in the beginning. There's just a couple of requirements. The major one is on voltage drop. For feeder conductors that run between the main service entrance and each of the branch circuits, there's a maximum voltage drop allowance of 2%. For those branch circuits that go from the branch to the actual outlet or load itself, there's a 3% maximum voltage drop. And this is in place to eliminate excessive loss through the lines, which is just another energy loss that we'd like to avoid with the code. A second building power requirement has to do with documentation submittals. The owner needs to receive information on the electrical design system within 30 days of the building being completed. This includes record drawings of the distribution system itself, which can include a single line diagram of the system, as well as floor plans that shows where the equipment is and the areas served by that equipment. A second part of this requirement are manuals and other documentation, some of which would be on equipment nameplate ratings. Another part would be operation and maintenance manuals for that equipment. And along with that, there's a requirement to provide contact information for qualified service agencies so that the owner can have equipment serviced when it needs to be. And finally, a complete narrative of the system and how it's supposed to operate so the owner will know perhaps when something is not going well. This completes and covers all the power requirements. We'd like to move into the majority of the requirements which are in the lighting section. And first, a bit about the scope. The lighting section does apply to new construction and additions. It includes all commercial buildings, and it includes residential structures if they are 4 or more stories above grade. If you have a residential structure, such as an apartment building, that's only 3 stories or less, then this would fall under whichever applicable residential code there is in the state or local jurisdiction. The code does cover both interior and exterior lighting, and there are some exceptions to all of these requirements. One of these is lighting within dwelling units. Taking that apartment example, if you have an apartment building that's 4 or more stories, the lighting must be covered. However, if it's within the actual apartment dwelling area itself, it is exempted. Now, this would not include common areas such as hallways, lobbies, common laundry room, common storage areas. Those would all have to comply with the standard, but not the lighting within the dwelling unit itself. A second exception is emergency lighting that's normally off. Typical example would be the battery pack lighting up on the wall that's wired such that when power goes out to the building, that battery pack comes on. A third exception, lighting required by a life, health, or safety statute, and that's exactly what it means. If there is a statute written into state or local legislation that requires lighting for a specific application, that could be exempted. One common confusion here is if a company has a corporate policy on design, for example, that says this is how we want our spaces designed. That does not fall under this exemption. These are only for actual statutes themselves. Historic buildings have a whole building exemption for all the requirements in the code. So if your building is on or capable of being on a national, state, or other historic register, the lighting within that can be exempted as well. Alterations and renovations is the other category that's covered under the standard. And generally, all of these requirements are treated the same. You generally have to comply with the requirements in the standard for an alteration and a renovation. There are some exemptions to that. Let's look at that in a little more detail. The requirements, as we said, are effectively the same for new construction and additions. If you replace the lighting such that it is the same as a new construction, then it must comply. If you are not replacing the lighting, it does not have to comply. Similarly with a control, if you replace the control, it has to comply. There's one general exemption for lighting, and it's on a space-by-space basis. You need to keep that in mind, not on a whole building basis, but an individual space basis. If you replace less than 50% of the luminaires in a particular space, then the requirements do not apply. It's only if you're replacing over 50% that the requirements come into play. So, having covered that, let's look at the basic format, a little bit of an outline of the requirements. There are 3 general sections: mandatory requirements that cover both interior and exterior, and they generally comprise some control requirements, switching requirements, and a couple of efficiency requirements. The other 2 sections, one covers interior lighting power limits, and the basic calculation or basic compliance path here is that the total connected power, your design power, must be less than or equal to the lighting power allowance that you're allowed in the standard, which is developed from the standard. We'll go through that in detail. Within the interior lighting power calculation, there are a couple of different ways to do it. One is by a whole building method, another by space, and we'll cover this in detail. There are some additional allowances to provide for flexibility, and again, we'll go over those. And there are some exemptions. The third category, exterior lighting power limits, similar in that your total connected exterior power must be less than or equal to the allowed power, again, provided through the standard, and we'll cover that in detail. A little bit different here in that instead of having a whole building in a space-by-space method, you have a couple of different types of applications, tradable and non-tradable, and we'll go over those in detail as well. And as with the interior lighting, there are some exemptions, lighting you don't have to account for, and we'll go through those as well. So let's look at the mandatory section. The basic overall requirement is for a control in each room or space enclosed by ceiling height partitions. There are limits to that. It's a fairly basic requirement, but there are limits in terms of how much can be controlled by each switch. So in a space that's less than or equal to 10,000 square feet, the control can serve can serve no more than 2,500 square feet for each control. So if you have a 10,000 square foot space, you're going to require at least 4 controls. If your spaces are greater than 10,000 square feet, that limit moves up to 10,000 square feet. Another part of this requirement is that control must be readily accessible to the occupants. That's the whole idea. They have to be able to turn lights on and off when they aren't needed. However, there will be cases where it's not practical to have this control available to occupants if it can be shown that there is a safety or security concern with having it available to the occupants. It can be a remote switch. There are some additional requirements to that remote switch. It has to be labeled what lighting is controlled, and you have to be able to see by some kind of indicator light that the lights are on or off. Other mandatory control on specific spaces. Hotel and motel guest rooms must have a control at the entry to the room for all permanently installed lights and switch receptacles. This eliminates the need for a guest to have to go back to the back of the room, for example, to turn off a light when they're getting ready to leave. Another specific space requirement is occupancy sensors for certain space types. The switch control in these spaces must be an occupancy sensor, and they cover classrooms, all except a few. The exempted classrooms are a shop or lab classroom where there might be a safety issue, and K through 12 classrooms where it's been shown that there's less occupancy, but all other classrooms must have an occupancy sensor control. Conference and meeting rooms in typical office environments and other building types must have an occupancy sensor, and employee lunch break rooms, lounge rooms, etc. must also have an occupancy sensor. There are some other mandatory requirements having to do with the lighting application, not necessarily a specific space, but the actual application of the lighting. One of those would be display and exit lighting, similar to the upper right photo where you're highlighting some displays or artwork. Another one would be case lighting. Lighting that's within a case is exempted. If you have task lighting, such as the desk lamp down at the bottom, that's not exempted. It has to have an additional control separate from overhead lighting control. Non-visual lighting, such as heating lamps in a restaurant, or as the picture in the lower right, an incubator lamp, those are non-visual applications that need to have a separate switch as well. If you have any demonstration lighting, that also needs to be separately switched from the general lighting. The primary major mandatory requirement is for automatic lighting shutoff, and this applies to buildings larger than 5,000 square feet. And another part of this requirement is that those individual switches that we just talked about must be able to override this automatic shutoff for a period of no more than 4 hours. So when occupants need to come in and do some work after hours, for example, they have the capability of overriding that automatic shutoff. There are some exceptions to this requirement. If you have lighting that's intended for 24-hour operation, of course, it makes no sense to have an automatic shutoff. If you have a patient care space, there's a potential safety issue, and so you do not have to have an automatic shutoff in those spaces. And similar, there might be a safety or security issue in another type of space other than a patient care. In this case, you will need to make the claim to the building official that there is a safety or security concern, and if they agree to that, then this requirement goes away for that space as well. Now, in terms of complying with this automatic shutoff, there are 3 ways to comply with it. The first would be a whole building ENCS or some other type of automatic time switch that would control the lights based on operating business hours, for example, in the various spaces within the building. There is a limit that the control can, each separate switch control can control no more than 25,000 square foot of space, or one floor at a time, regardless of the size of the floor. Those are some limits, such that occupants can have a little bit of flexibility in which areas of the lights go off automatically at which times. A second way to comply with this, in some cases a little simpler, is an occupancy sensor. These must be the types that turn off lights within 30 minutes of the occupant leaving the space. If you were to install occupancy sensors in all spaces in the building, you would then comply with this requirement. A third method is some other type of signal, and there are some systems out there tied to workstations or computers that would provide some kind of a signal that indicates the space is occupied, and that would also comply with this requirement. One note here, earlier versions of the 90.1 standard have had, and other standards as well, have had this third or a second option be listed as occupant intervention, and that has caused some issues in that's been interpreted as being a manual wall switch. That has never been the intent. It's been a typo from the beginning, so it must be an automatic switch to comply with this provision. And a final note on automatic shutoff in terms of how this is applied. It's meant to apply to a business entity or structure that has specific operating hours, because the automatic shutoff is based on occupancy, which could be tied typically to occupancy hours. So a good example of this might be a strip mall where you have a business or several businesses that may be less than 5,000 square feet, but the building itself is over 5,000 square feet. So the actual language would say that an auto shutoff control is required here. But this really isn't practical in that each of these strip mall businesses might have different operating hours. So again, the intent is business entity of structure. So a strip mall with small units, if the unit is less than 5,000 square feet, will typically not have to have this requirement. Similar examples may be out there. This is just a good one to highlight that. So that pretty much covers the mandatory requirements for interior. There are some mandatory requirements for exterior lighting. And the basic requirement is for night, for outside dusk to dawn lighting, where you want lighting when the sun goes down. You can have either an astronomical time switch or a photosensor to control that lighting. You must have one or the other. For any other exterior lighting that's not tied to dusk to dawn, in other words, perhaps only on part of the evening, you can have either an astronomical time switch or a combination of a photosensor and a time switch. It does the same thing. Note, this is the first section. I mentioned I'd highlight changes from the 2004 to 2007. This is the first notable change for 2007. It really doesn't change the requirement in this case, but it clarifies what's possible. There were some issues before of not being able to use either of those, and now it's been clarified that either of those meet this requirement. All of the switches that would comply with this requirement must have at least a 10-hour battery backup, so if power goes out, the control system and the timing is not lost. There are exceptions. If you have a covered vehicle entrance or an exit from a building or parking structure, and if there's a safety or security concern or an eye adaptation issue, then you can claim an exemption. Again, you would need to make your case to the building official to claim an exemption for that. A couple of other final mandatory requirements. One on tandem wiring. This has to do with the use of low frequency, typically also called magnetic ballast. As you're aware, most of these are based on operating a one or two lamp system. In a typical 3-lamp fixture, you might have two ballast. One drives two lamps. One drives a single lamp. The problem is that ballast driving a single lamp will have the same losses whether it's driving one lamp or two lamps. So the requirement says if you're using that low frequency ballast, you must tandem wire it so that it's driving at least its full two lamps. Now, if you're using high frequency ballast, typically electronic ballast, this isn't a concern. It's only when you're using those low frequency ballasts. Not much use of that these days, but it's still in the standard. The final mandatory requirement has to do with exit signs. Simply, they must be 5 watts per face or less, and that's easily achievable today with newer technology, including LEDs. That completes the mandatory requirements. So let's look at the interior lighting power requirements, that second major section. The lighting power is based on a prescriptive path. It has two methods, as we mentioned, whole building or space by space. And the basic requirement is you compare your actual installed designed power, your wattage, with the allowed wattage provided in the standard. And if you are less than that allowed wattage, you comply. There are, as we mentioned, and we'll cover in detail, additional power allowances and exemptions that provide a lot of flexibility because lighting designs are quite variable across buildings. One other small point I want to make here, just talk a little bit about another compliance option other than the prescriptive option, which is the performance option, or sometimes referred to as the energy cost budget. This is typically used for larger buildings with usually more complicated systems or advanced features. It's a whole building modeling process where you have to model your entire building's energy use, and you model it based on what a prescriptively compliant building might use. Then you compare that to your building's energy use, and if you're using less, you comply. This does provide flexibility, especially if you're using advanced features. However, it requires a lot of detailed modeling inputs. It's only usually used for larger, more complicated buildings, so we're not going to provide any more detail on that. We're going to stick with the prescriptive option, which is the most common. So the first step in completing the prescriptive option is to determine your installed lighting power. And this is essentially calculating the installed wattage for all of your spaces. This must include all of your permanent and portable interior lighting if it's part of the actual design. The design would include general, ambient, cast illumination. So anything that's part of your design has to be included. There's one exception to this if you have, as it says, two or more mutually exclusive systems. In other words, if you can only operate one or the other, they're actually tied to be exclusive, then you only need to count the wattage of the highest one because only one can be on at any one time. So the calculation, there are some rules to this calculation, and I'll go through those here. For a standard incandescent type source, for example, a recessed can light, the rule is you must use the maximum labeled wattage of the luminaire. As you know, the luminaire will come with a label that says the maximum rated lamp is X watts. That's the value you must use. As some of you will know, there are manufacturers who will provide the appropriate label for your use. If you're buying a standard fixture and you never intend to put in higher than, say, a 60-watt lamp, you need to have a lamp provided with that sticker so that that's the value you can use for compliance. For luminaires with ballasts or transformers, typical linear fluorescence, CFLs, it's always been the wattage of the maximum lamp ballast combination, not just the nominal wattage of the lamp. You have to include the ballast losses. However, new for 2007 is the added words that you can use the maximum labeled wattage, similar to for the standard incandescent rules. This eliminates some of the problems with a multi-cap or multi-level ballast, which is labeled for higher level use. But if you're intending only to use it at a lower level, then you can provide the appropriate label luminaire and only have to count that in your calculation wattage. For line voltage track, the typical rule has always been the actual wattage of the heads or a minimum of 30 watts per foot. However, in some cases, 30 watts per foot might be more than you can actually put on there. So a couple of compliance options have been added in 2007. One says it can be the wattage limit of the system circuit breaker, which makes sense. If you can't go any higher than that, you shouldn't have to be claiming anything more than that. A second option is if you are installing a permanent current limiter on that track system, you can use that value as well. Again, that permanent limiter sets the maximum you can put on it, and you shouldn't have to be forced to claim anything more than that. For a low voltage track, when you're calculating that, it's the transformer wattage supplying the low voltage track, and anything else is the actual lamp plus ballast or lamp wattage rating supplied by the equipment manufacturer itself. So, as we mentioned before, there are some exemptions. This is wattage that you do not have to include at all when you're doing the calculation. And I'll go through these briefly, noting some of the highlights here, just for clarification. The first one, theatrical, stage, film, video production. This is only the lighting for production. It's not all the lighting in an area that, say, is used for video production. If you have overhead lights, those still have to be counted. This is only the lighting that's used for the actual production itself. Lighting used only during medical dental procedures. Again, the overhead lighting is fair game. It would only be the actual articulated lamps, for example, used during exam or procedures. Display and exit lighting in exhibits for museums, monuments, and galleries. This again would be just the lighting that's aimed at displays or exhibits, not any type of overhead lighting. Plant growth or maintenance. Again, these are non-illuminating sources, so they don't have to be counted. If you have lighting that's part of equipment that's installed by the manufacturer, you don't have to count that. Similarly, lighting that's part of a refrigerator or freezer case that comes from the manufacturer that way, that doesn't have to be counted. Food warming and food prep equipment, again, is not illumination. It doesn't have to be counted. If you have a retail display window that's enclosed, in other words, it doesn't share space with the retail floor, that lighting is exempted. But again, it can't be open to the retail sales floor itself. This next one was in the earlier version noted as lighting in spaces specifically designed for those with visual impairment. This has been revised and further clarified to note that if you design a space specifically for, and it's been enlarged to say visual impairment or other medical and age-related issues, you can exempt that lighting. But again, it's been tightened up a little bit in that it has to be designed specifically for that application, not just potentially used for those kind of occupants. Another one, if you have lighting in a space designated as a registered historic landmark, as we mentioned, that was an exemption. It's listed here as well. If you have lights that are part of a sign, again, it's part of the equipment that comes from the manufacturer, that's exempted. Exit signs are exempted. Now, you'll recall there was an exit sign requirement. The exit signs do not have to be counted in the wattage calculation, but the other requirement that they must be 5 watts per face is still in place, so both requirements apply. Sale for lighting or educational demonstration systems does not have to be counted. For television broadcasting and sporting activities, again, similar to theatrical production, it's just the lighting used for the actual television broadcasting. All the other general lighting has to be counted. Casino gaming areas. If it's a gaming area, the lighting is exempt. If it's a termed back-of-house area where there isn't casino gaming going on, those lights still have to comply, but the gaming area itself can be exempted. A new one for 2007 is if you have task lighting that's furniture mounted and it has an automatic shut-off provision, such as an occupancy sensor, it can be exempted as well. Now, this completes the half of the process. The other half is determining what your allowed power is. And the process is to choose the appropriate lighting power density. And as we mentioned, you can do this in two ways: whole building or space by space. The whole building method is easier, but it provides less flexibility. In this case, you get one number for the entire building, apply that to your square footage, and that's your allowance. For space by space, you have to do more math, but you do get more flexibility. In this case, you look at each individual space, calculate the square footage for that, and apply an individual LPD. Can provide more wattage that way. Again, the last part of that is you multiply the lighting power density by the square footage, either whole building or space by space, and the total of that provides your allowance. So let's look briefly at these lighting power densities, give you an idea what they look like. The first is a list of space by space LPDs, and what you're seeing here is just a small sample of the actual requirements in the standard. There are a little over 100 different space types in the standard, so you do have quite a bit of flexibility. You'll see at the top some common space types. These will be found in lots of different buildings, the same value whether you use it in an office or a restaurant, for example. Then you'll get down to specific building type spaces. And for example, there are 3 hospital healthcare items in there for 3 different space types: exam, treatment, emergency recovery. There are even more hospital healthcare categories, but we just provided 3 here. You'll notice that the lighting power densities are different for each of those because the lighting requirements are different. They range anywhere from a very low 0.8 up to 2.7, depending on the application. Let's also look briefly at the whole building LPDs. These are based on the space type LPDs, but it's one number for the entire space. I did want to just to point out, we mentioned before the flexibility of using the space by space method. If you look at the hospital line item there, it's a lighting power density of 1.2. As you'll recall, you had lighting power densities up to 2.7 for hospital healthcare spaces. So if you have a lot of the space in your hospital that's at the 2.7 level, you may find it's a lot more advantageous to use the space-by-space method and take credit for that extra wattage. So a couple of words here on where these numbers came from. There's often been a concern that these were just developed not randomly, but maybe just by a consensus of a small group without any backup to them. And that's not the case. These are developed within a committee, the ASHRAE IESNA 9.1 Lighting Subcommittee, with IESNA committee support. It's a similar process starting in 1999 through the current version. The process is to apply 4 basic types of information. The first is current lighting product performance data, efficiency of current products. Also current lamp and ballast efficacy and light loss factors. Light loss factors were approximately the same since the 30s until about 1999 or 2000 when some new information came out, and that new information has been incorporated in the later models. The latest IESNA recommended light levels are also part of this process, as well as some professional consensus of the way typical design happens and the lighted environment itself. All the information associated with these 4 categories gets combined into some lighting space models to actually calculate what an appropriate lighting power density would be to meet these kinds of quality designs. That's the basis for the approximately over 100 different space type models. So then what about whole building LPDs? The whole building LPDs are developed directly from these space type models. What was needed, of course, was an idea of what a typical building entails in terms of how much square footage is office, hallway, etc. So there was a source of construction data access, the Dodge construction data. Building plans were required for brand new buildings because this is a standard for new construction primarily and new renovation. Detailed takeoffs were done for those buildings to come up with what the square footage of each space type was within those. This is based on a current set of 246 buildings across 31 building types, and for each calculation of space type square footage, the appropriate LPD was multiplied by that, and you get a weighted average of that typical building. You then do a weighted average of those buildings across a building type. So each of the office buildings that were done was averaged with all the other office buildings to come up with a whole building LPD. Now, if you'd like more information on this process and how it works, there are details available for it on the IESNA website. You can go out to this link and you can see the whole process. There's some documentation of the process itself and active links, so you can actually look at where all the numbers come from. So if you have questions, please feel free to go out there. Take a look. Now, one important part of the interior calculation are additional lighting power allowances. These are specifically put in the code because the code can't cover everything, and lighting is has a lot of art to it. There needs to be a lot of flexibility. So there are some additional lighting power allowances. These are use it or lose it allowances in that you can only use them for the specific design use. You can't use them for general illumination or for any other applications. And these need to be separately switched from the general lighting as well. This provision for separately switching was reinforced in the 2007 version with some tougher language, noting that it must be automatically controlled separately from the general lighting, and it needs to be turned off during non-business hours. So a little tighter language there. To cover these, we want to cover in a little more detail each of the allowances. There are 3 of them. The first one is for decorative luminaires in addition to general lighting, and a typical example might be a chandelier in a lobby. There might be some general overhead lighting and then 1 or more chandeliers as decoration. This would be a classic example of an application that would provide the allowance. And this is 1 watt per square foot for the area that those chandeliers are meant to decorate. A second allowance, which is not applied much anymore but is still in the standard, has to do with designing typically an office environment to eliminate computer screen glare. And those of you that are familiar with it, there is an IESNA document that describes this design feature. With flat screens and better lighting systems, this really isn't done much anymore, but for those who still do it, you can claim a 0.35 watts per square foot allowance if you're following all the design criteria in that procedure from IESNA, and that's spelled out in the code itself. The third category, the most often used, one that requires the most detail, is on retail display lighting. And this has been totally revised, actually replaced, for the 2007 version. Some of you may be familiar with the 2004 provisions that provided 2 additional lighting power levels. They were hard to apply because it was hard to define when you needed either and how to calculate display areas, etc. So this has now been completely revised. As you can see, the simple calculation at the top is you get a flat 1,000 watts if you have articulated display lighting. And depending on the type of merchandise, the retail area type, you can get additional power as well. The 2 big changes here are that there are now 4 categories with better defined merchandise types, and the allowance is no longer based on display area, which is sometimes hard to calculate. It's now been backed off to apply to the retail sales floor area itself, so it's a much easier to apply. The compliance has been calculated so that it works similar to the process before. It's just a lot easier to apply. So if you look at the detail, it says where retail area 1 equals, there's a description there of what type of merchandise applies to each of the areas. So retail area 1 is basically a catch-all for anything not listed elsewhere. And retail areas 2, 3, and 4 have specific merchandise types. Notice at the bottom, there is an exception such that if you have a merchandise type that is not included in areas 2, 3, or 4 above, you can make your case to the billing official and discuss it with them and come up with an appropriate category for your merchandise type. And if they agree with it, then it can be placed in that category and you claim that allowance. So that basically completes the interior lighting power requirements. Let's go to the exterior lighting power and look at what those requirements are. There's one miscellaneous requirement having to do with building grounds lighting, and this basically states that if you have lighting luminaires with sources that are over 100 watts, those sources must have an efficacy of at least 60 lumens per watt. Now, what that means is that for higher wattage lamps, you're not going to be able to use incandescent for those applications. But for smaller wattage lamps, that wouldn't be a problem. The basic requirement for exterior is on lighting power densities, similar to interior. And as we mentioned before, the applications are split into 2 categories, tradable and non-tradable. Tradable, these are applications where if you don't use all the wattage for one application, you can use it for another. And we'll explain that a little bit more. An example might be if you have a parking lot and you don't use all your wattage in the parking lot, you can then use what's left over for, say, canopies. The non-tradable applications are applications where you're given a certain amount of wattage, but you can only use it for that application. It cannot be traded anywhere else. So let's go into a little more detail here. The basic compliance format is that you have the total exterior lighting power allowance is calculated as the sum of the individual lighting power densities. You are allowed an additional 5% adder on top of that. This is different than the interior application. This provides additional flexibility. There's always something that isn't considered, and so flexibility is built into the standard. And of course, there are some exemptions, and we're going to go over those in detail. Let's look at the actual lighting power density allowances. First, let's start off with tradable surfaces, and I'll go over these in a little bit of detail so you can understand what they actually are. These, again, are tradable surfaces. You can trade this wattage within any of these applications. Parking lots and drives under uncovered parking areas, you have an allowance for those. These are uncovered parking areas. Remember that if you have a enclosed or covered parking lot, that's covered in the interior table, not in the exterior table. For building grounds, there are several applications For walkways, there are two ways to account for this or provide allowance for this. If the walkway is less than 10 feet wide, it's 1 watt per linear foot. If you have a walkway that's greater than 10 foot wide, then you need to calculate it on a square footage basis. So it would be 0.2 watts per square foot of that area. Also included in this category would be plaza areas, special feature areas, again based on the square footage of that area. If you have stairways, they are counted at 1 watt per square foot. And if we go to the next slide, you'll see more tradable applications, building entrances and exits. Two categories here, main entries, and this is, the main entry would be the primary entrance for not the occupants or the staff, but for the public. So the main entrance gets 30 watts per linear foot of door width. This is actual door width, it's not a square footage. For all other doors, employee entrances, exits, loading areas, etc., those are provided 20 watts per linear foot. Another tradable surface, canopies and overhangs. These can be freestanding or attached to the building. They get 1.25 watts, again, per square foot, so you calculate the square footage of the canopy itself, or at least the square footage of the area that it's covering. Outdoor sales, you have two applications. One is for an open area, and such as a vehicle sales lot, 0.5 watts per square foot. You can also add to that, if you have street frontage next to a street of your sales lot, an additional 20 watts per linear foot. Now these two can be added together. As long as you have street footage, you can add that wattage to the wattage for the open area. They're both allowed to apply to the same area. So that's it for tradable surfaces. Let's look at non-tradable surfaces. And again, these you get a specific wattage allowance, but you cannot use it for anything else. Building facades is the first category. Unlike the open sales area we just talked about, while there are two ways to calculate this, you cannot claim both of them. You must use one or the other. So you can either apply this at 0.2 watts per square foot for the surface itself that you're going to illuminate on the wall, or 5 watts per linear foot for the actual linear length of the base of that wall. You can calculate this either way, but you can only do it one or the other. You could, if you had two facades, do one calculation one way, the other area the other way, but you can't use both on the same facade area. Another non-tradable application, automated teller machines and night depositories. It's a flat 270 watts per location, plus 90 watts for additional machines. What this means is if you have an ATM location on one side of the building with one machine, you get 270 watts. If there's another machine right next to it, the same location, that's an additional 90 watts. If you had two machines, but they're each located on opposite sides of the building, each location would get 270 watts. It's only the additional machine in the same location that only gets another 90 watts. Entrances and gatehouse inspection stations at guarded facilities. These are uncovered areas again, 1.25 watts per square foot. If you have a covered area, of course, it's included in the canopy and overhang sections. You need to go there for that. Other non-tradable surfaces. Loading areas for law enforcement, fire, ambulance, etc., 0.5 watts per square foot. Again, this is uncovered area. Covered areas are included in canopies and overhangs. Drive-up windows at fast food, and of course this would apply to other building types such as pharmacy and banking as well. If it's a drive-up window, you get a flat 400 watts per drive-through. Parking near 24-hour retail entrances. In the case of, for example, a mini-mart type gas station application where you need extra light at the front entrance, you can get an 800 watts only per the main entry. This doesn't apply to any other exits or back entries, for example. And those are the requirements. There are also exemptions, as we mentioned, to the exterior lighting power. A lot of these you'll see are similar to the interior exemptions, but there are a few different ones. The first one, specialized signal, directional, and marker lighting. This is typically found in exterior applications. That can be exempted as well. Lighting integral to advertising signage. Again, it's a part of the sign. It comes from the manufacturer. It's exempted. Also, lighting integral to equipment is exempted. Similarly, for theatrical purposes, again, this is just the lighting for the theatrical purpose, not any general lighting. Lighting for athletic playing areas. lighting that's used for the playing area itself would be exempted, but not other auxiliary areas. Temporary lighting, of course, is just temporary. It doesn't need to be counted. Lighting for industrial applications, material handling, transportation, etc., that lighting can be exempted also if it's considered that classification. Theme elements and theme amusement parks. And again, similar rule as casino gaming areas. If it's part of the theme element, it can be exempted, but standard lighting, back-of house operations, other general area lighting would have to be counted. And again, lighting used for public monuments, historic landmarks, etc., that is exempted as well. This completes the exterior requirements as well as the requirements in the entire lighting section of the standard. If you need some more information, there are some resources here, some websites you can get information on the 2007 standard itself, ASHRAE.org and IESNA.org. More information on the standard and compliance tools available at energycodes.gov. And that concludes the presentation portion of today's event. Thank you. One note about availability of the 90.1 2007 standard and ComCheck tools that would incorporate that. The 2007 is not out quite yet. It will be coming out soon. The requirements are set. It's just a matter of getting a printing date set. And ComCheck will follow later during the 2008 year with provisions for compliance with the 2007 standard.
Well, thank you very much for an informative webcast, Eric. And thanks to all of you. The U.S. Department of Energy appreciates your attendance today. Before we begin answering the questions that have come in, I'd like to put up the link where you can provide us with your AIA information or print a certificate of completion. Now for the questions.
Okay, thank you, Rose. And I'll go through these as quickly as possible while at the same time trying to provide a good answer. First question, why is there no uniformity of code regulations across the region? This could apply across states and regions, I guess, is the question. States are required by ECPA and then EPAC to adopt a code that meets or exceeds a certain level set by DOE, but that's the only requirement. There's no requirement that it be the same as any other state. So if a state finds a code or develops one on their own that meets that requirement, they can adopt it. And fortunately or unfortunately, this means there isn't a lot of uniformity necessarily. You'll find a lot of states that have the same code, but you'll find a lot of variation as well. Another question, working on 4-story buildings where the first floor is retail and the top tier residential. So is the residential exempt or not? No, even though there's a note in there about the standard covers 4-story and above residential, that means a completely residential building. Because this building has a retail element to it, the first floor, it is therefore considered a commercial building, so it would have to comply with the commercial code. Question, are licensed assisted living, long-term care, supportive living buildings commercial or residential occupancies? Even though they have residential elements, they are a commercial facility. There can be a fine line there depending on how much care is provided, but in this case there is a commercial element. You are providing care to the occupants, so that would be considered a commercial building. Another question, did historic buildings have any exemptions? Yes, there's essentially a whole code exemption if your building is or can be placed on a historic national state register, then it can be exempted from the energy requirements. Question, exemption for 50% of a space, what constitutes a space? If you are doing a section of a tenant floor, but it isn't 50% of that floor, is it exempt or is it by space or room? It's by space, and by space it's any area with ceiling height partitions. It's not by tenant area. So any space within that tenant refit that has more than 50% of its lights being replaced would have to comply with the code. Another question on a similar question, definition of a space. Essentially, ceiling, any space, any area surrounded by ceiling height partitions. The other term used in the standard is enclosed. If it's not enclosed, it's not really considered a space in terms of the standard. Question on the occupancy sensor requirement. What classrooms are left if all K through 12 classrooms are exempt? What's left are all college, university, adult education, community education. It's just the through 12th grade classrooms that are currently exempt from that requirement in the code. Another question on the safety or security concerns exemption. Question actually asks, how do you prove safety or security concerns? Good question. This is something where you, as the builder or the builder or designer, would have to make your case to the building official, cite some issue or make a claim of why there is a concern there. Take your best shot at it, and hopefully the building official will agree. This is one of those areas, unfortunately, there's no way to really define what that is. In some cases, you'll have a regulation or statute you can rely on. In some cases, not. If you don't have one, then you'll have to make the case yourself. Another question on requirement for the auto shutoff. Does this requirement control all lighting but exclude life safety lighting? Yes, there was an exemption for life safety issues. If you have made a successful claim for certain lighting that's a life safety issue, then that part would not have to be controlled by the auto shutoff. On voltage drop, are the voltage drop requirements now mandatory and enforceable? They are mandatory. They're part of the standard. They have been for several versions. Good question on enforceability. This requirement is complied with at the design stage. So the electrical designer would look at the loads expected in the building and determine what kind of wiring is required to meet these voltage drop requirements. After occupants move into the building, it's possible that those voltage requirements wouldn't be met because of excessive loads or different types of loads. But at this point, these building energy codes are based on verifying compliance at the design stage. So that's about as far as it goes. The enforcement part would come in looking at the design and seeing that the electrical designer did verify that this will be the case. Question on illuminated wall definition. Is it based on the total wall area that can be potentially illuminated or based on the actual illuminated area itself? The intent is that any portion of the wall that the design intends to illuminate will get credit. If you intend to illuminate the entire wall and you have the lighting power to do that, then you could claim the entire wall. In some cases, you're only intending to illuminate the bottom half or a certain portion. That would be the area that you get a claim for. Question on signage. Would signage qualify as a form of exterior lighting? Yes, and as you recall, there are some exemptions for signage. If it's part of a transportation system, that can be exempted. If the lighting equipment is actually part of the sign itself and comes from the manufacturer, that would also be exempted. Question on, can spring carryover time clocks be used instead of battery backup? I'm not particularly familiar with what a spring carryover system is. Maybe that's a mechanical system, I'm not sure. But the code is fairly specific in that you have to provide battery backup. So a battery backup, which are very common, is the only type that would meet that requirement in the standard. A question on the hotel, motel, guest room entry lighting control. The question is, what manufacturers have responded with products and how do they work? A little bit of background here. The lighting subcommittee that develops these standards does verify that equipment available from multiple manufacturers on the market to meet the requirements that are put in the code. But the standard does not specify what kind of equipment has to or can be used. That's left up to the individual to choose. Typically, this kind of hotel, motel, guest room entry control would be could be just a single power cutoff switch upstream of the lighting receptacles, or it could be a similar relay switch that forms the same function. There are probably more advanced versions that those simple kind of systems would comply. Question on performance incentives. What are the considerations for performance incentives? And I believe the question is referring to if you have advanced controls or better control of the building so that your energy use is low, maybe compared to another building. If you are basing your compliance on energy performance and not on connected load, you'll at this point need to use the energy cost budget whole building modeling method that we mentioned briefly. That's where you might get extra credit for advanced controls or performance. Question on a spec office building. If you're building a spec office, how do you account for potential task lighting to be utilized by the tenants? The rule here is if the task lighting is part of the overall design, it must be included and counted as part of compliance. if you design a building with, say, just overhead lighting, and that meets the requirements of the building owner, meets IES recommendations, et cetera, whatever your design criteria is, and then occupants move in later and provide some additional task lighting, that's a separate issue. It doesn't interact with the code. The code only looks at the design itself. If you only provide a partial design and say, well, the occupants will move task lights in later, that's not really a complete design, and you have to use complete design when you go to show compliance to the standard of the code. Another question related to task lighting. Please confirm task lighting is no longer exempt. This would include cord and plug connected luminaires. Task lighting has never been exempt. It's always been considered part of the compliance path if it's part of the design, except, of course, of the one new exemption we just mentioned. If it has an auto shutoff, it can be exempted. Cord and plug, again, these typically are hard to be part of an initial design, and so likely these are things that come in later and wouldn't be considered by the code. But if they are part of the initial design, then they must be counted. Question on industrial manufacturing buildings. I believe this relates to control, both for auto shutoff and for space control. It does apply to these areas unless there's a specific exemption. For interior, this certainly would apply. However, there is the exemption for safety security issues for auto control, for example, and I believe maybe this is what this question is getting at. And again, if you can show that there's a safety or security concern, then you can have remote control of that lighting switch. There are some requirements to that, though. It must be it must have a indicator light and be labeled such that the user of that switch knows where the lighting is. Another question here on exterior lighting. Is an outdoor flagpole considered an exempt public monument? Good question. If it has some national historic significance, then of course it would be exempted. Simply placing a flagpole in front of your building because you want to fly the flag wouldn't necessarily be considered a public monument unless there's some ruling or regulation that states so. This could be an issue you'd have to take up with the building department. If you believe there is a claim that it's a public monument, you could ask for that exemption. But typically, I know of no statutes that simply exempt that in general. Another question on the 50% rule for alterations. When completing a lighting alteration, if more than 50% of the luminaires are replaced, but controls are not replaced, does the code apply? In that case, if you're replacing more than 50% of the luminaires, the requirements associated with the luminaires, basically the lighting power density limits, would apply in this case. But since you are not replacing the controls, none of the control requirements would have to be complied with. Question on inspection plan review for permanent current limiting devices on track lighting. How would a plan reviewer, inspector, field verify this? Typically, this equipment, like any other equipment, should be on the plans or in the specifications. Likely this will be visual. However, the real issue here would be if it is being claimed by the building owner or the builder that they're claiming the current limiter as their calculation for track lighting. The onus is on them to provide information on that current limiter and be able to show it to you when you might come out to inspect. Question on the 2007 code. Has the code addressed the lighting pollution concerns for the dark sky initiatives? This was discussed a lot in development of the exterior requirements, and a lot of attention was paid to it. However, the critical issue here is that the ASHRAE 90.1 standard is an energy standard. It deals specifically with what is reasonable to require a building to do in order to save energy. And sometimes this falls with, sometimes it does fall within the purview of saving energy, but not always. Hopefully they are not at odds. But the 2007 code doesn't make any specific considerations for dark sky issues. However, as you'll know, for example, full cutoff fixtures make a more efficient use of a light, and therefore it's easier to comply with the code. in that respect. A note here about a previous question on compliance and the ASHRAE police, for example. DOE does not set the standard. The state or local jurisdiction that adopts the code is the enforcing entity, and they essentially would be the code police. As I mentioned, the state adopts a code. It's up to that state, or if they pass it down to local jurisdictions, to do the enforcing of those codes. One more question. Let's see here. Can you suggest where to go for clarification of the energy cost budget procedures? Specifically, do the renovation exemptions apply? The energy cost budget is whole building modeling. It doesn't include very many prescriptive requirements other than you have to meet the basic prescriptive requirements. It would be treated the same as a whole building, except that you would only be doing part of it. I would suggest going to the appropriate chapter in the standard and reading the, and I believe it's chapter 11, and reading the introductory information. It'll give you all the information you need on how to apply the energy cost budget. And I believe that's all we have time for.